In lesson 5.7, we are talking about real-world triangle problems, and we're focusing today on oblique triangles, so triangles that do not have a 90-degree angle in them. So in example 1, a surveyor measures the three sides of a triangular field and gets 114, 165, and 257 meters. What is the measure of the largest angle of the triangle, and what is the area of the field? So let's start by drawing a triangle. And we're going to label it. You can label it whatever you want. I'm going to call it ABC. And then I'm going to label the sides that they gave me in the problem. So we've got 114, 165, and then 257. Okay, so that is the setup that they give me in the problem. Now part A, they want us to find the largest angle. Okay, largest angle. So we need to decide what is the largest angle. So right now, ask yourself, which one do you think is the largest? And we know in geometry that the smallest angle is opposite of the smallest side of the triangle, and the largest angle is opposite of the largest side of the triangle. So hopefully you were thinking to yourself, B is the largest angle because it is across from the largest side. So that is what they want us to find. All right, so to do that, I'm going to use law of cosines because in order to use law of sines, I would need opposites. I would need some sort of angle here, and I don't have that. Because I have side, 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 I'm going to have to use law of cosines. I'm going to use law of cosines where the angles have been solved for. So I'm going to use cosine B equals negative b squared plus a squared plus c squared divided by 2 times a times c. And when we plug in our numbers, we're going to put parentheses around the numerator and denominator when we plug that in. So now I'm going to fill in those values that were given to me. So because B is across from 256, that is side B, according to my triangle that I have labeled, or 257, sorry, squared. And then A in my triangle is 165, and C in my triangle is 114, all divided by 2 times A and C. Okay, we're going to type that into a calculator, and then we're going to take the inverse cosine of it. So I'm going to go to Desmos and use their scientific calculator. And so the top, negative 257 squared, plus 165 squared, plus 114 squared. I'm going to exit out of the parentheses and divide and put parentheses around my denominator. 2 times 165 times 114. Get out of that, and you can see over here that we are getting negative 0.6865. 6865. Okay, so that is what cosine of B equals. Hopefully you're not thinking that that is a reasonable answer for an angle measurement, because we still need to take the inverse cosine to the other side. Normally we don't get angles that small unless the problem would make sense for it to be that small. So we still need to take the inverse cosine of the other side, and we're going to be in degree mode for this. So I'm going to go over here. I'm in degree. I can see that right there. And I'm going to find the inverse cosine of that answer that I just got, and I'm getting 133.4. 133.4 is my answer. We got an obtuse angle, which makes sense because we were looking for the largest angle. So that works. And now it doesn't have to be obtuse. It just happens to be obtuse. All right, B, what is the area of the field? So now that I have 133.4, I'm going to go ahead and label that in my picture. And in order to find area, you need side angle side. Area requires side angle side. So I am going to have, since I only have B, I'm going to have to use sides A and C. So that would mean if I look at my area equations, I'm going to do area is 1/2 AC sine of angle B. So if I plug in my numbers there, A is 165, C is 114, and sine of angle B, 133.4. I'm going to type that into my calculator. So I'm going to do 1/2 times 165 times 114 times the sine of 133.4, and it is giving me 6,833.43. Okay, if I go back here, does that make sense? It's a really large area, but we are talking about a field, so this does make sense in the context of the problem. My units are meters, so I'm going to go ahead and put, or meters squared since we did area. And then over here, check your units, I do have degrees. So my answers seem reasonable, and I have units and everything checks out, so it looks like we've done example 1 correctly. Now let's move on to example 2. As Ivan approaches 2 satellites, he finds that one of them is 8 kilometers from him and the other is 11 kilometers. And the angle between the two, with Ivan as the vertex, is 120 degrees. How far apart are the satellites? So we've got Ivan, an astronaut in space, or maybe a robot, and he is between 2 satellites. He finds that one satellite is 8 kilometers from him, and he finds that the other satellite is 11 kilometers from him. And then it says the angle between them with Ivan as the vertex, which is why I drew it this way, is 120 degrees. So this angle here is 120 degrees. How far apart are the 2 satellites? So they want this distance here. So if I'm going to label this, let's label it ABC again. And they want this distance, which would be side B. So you need to decide whether you can use law of sines for this or law of cosines. In order to use law of sines, you would need opposites. So I do have an opposite here with B and angle B. So I'm looking for side B and I have angle B. But I would need some sort of opposite with A or C. Now I have side A, but I don't have angle A. And I have side C, but I don't have angle C. So I don't have enough opposites to set up that proportion that I would need for law of sines. So that's telling me that I need to use law of cosines instead. So what I have here is a side A, a side C, and an angle B, which if I look at my law of cosines properties or formulas, I do have one that says B squared equals A squared plus C squared minus 2AC times the cosine of angle B. And that matches with everything that I have, since I have A, C, and angle B. So I'm going to go ahead and fill in my numbers that I have for that. So that would be 8 squared plus 11 squared minus 2 times 8 times 11 times the cosine of 120. I'm going to go to the calculator and type that in. So I'm going to Desmos, and I'm going to type 8 squared plus 11 squared minus 2 times minus 2 times 8 times 11 times the cosine of 120. I'm in degree mode, check that, and I get 273. Now that is really big. It could be correct. We are talking about space, but it doesn't really compare to my 8 and my 11 in the picture. So what I'm forgetting is I still need to take the square root of that. So square root of 273 is 16.5. So looking back here, I got b squared was, what did we have? 273. And then what we needed to do was take the square root of both sides. So we square rooted this to get rid of the square, and that's how we're getting 16.5, which makes more sense with the other measurements that we have in the picture. So B is 16.5 kilometers, and that is the distance apart from the satellites. So really what you need to do in these word problems is read the problem, draw a triangle, label it with the information they give you. Also label it with some variables. I like to use A, B, C because that's how we wrote our formulas. You then need to figure out which formula goes with the information provided. In these two examples, it was law of cosines, but it could be law of sines. Plug in the appropriate numbers into the equation and solve for the missing variable. And then always go back and make sure that your answer makes sense in the context of the problem.